Hello everyone and welcome back. So you already know what is Gauss Divergence Theorem, and we also know some applications of Gauss Divergence Theorem. Now in this particular lecture we will learn some more important and very interesting examples of Gauss Divergence Theorem. So let us begin. Now see, in this first problem it is given that we have to evaluate double integration over S r bar dot n cap ds. So in general in the formula we have written f bar dot n cap. So here it is written r bar dot n cap ds, where S is a closed surface. Now no specific information is given, only it is given that S is a closed surface and the volume is V, and we know that n cap is the unit vector or outward roll normal on the surface. Now we have to use Gauss Divergence Theorem. We know that using Gauss Divergence Theorem, this is the relation. Gauss Divergence Theorem is the relation between surface integral and volume integral. So r bar dot n cap ds is equals to how much? Triple integration over v nabla dot r bar dv. Okay, so nabla bar is what? I del x plus j del y k del z dot r bar. So r bar we can write x I cap plus y j cap plus z k cap and then what? dv. So now we have to find the dot product. So it's triple integration over v. Now I cap dot I cap is what? 1, right? I cap dot I cap is 1. So what we have then? Del x of x. Derivative of x is how much? 1. Other term will become 0 because we know that I dot j is 0. Similarly, I dot j is, so I dot k is what? This is also 0. So we have only 1. So in the same way, del y of y, derivative of y is 1 and derivative of z is what? Also 1. So what we have? 1 plus 1 plus 1 is 3 integration over v dv. So generally, we have to, in place of dv, we have to write, if the limit of x, y, z is known, then dx, dy, dz, then appropriately we will integrate. But here, only the surface is given, S is the surface, nothing is mentioned. So we'll just simply integrate it. Integration v is how much? Like integration dx. Integration dx is what? Integration dx is x. So like this, integration dv is what? V. So it is 3v. Okay, so this is the answer. Now let us take a similar example. Here, just you see in place of f bar, or when you write the Gauss Divergence Theorem, it's f bar dot ds, then nabla dot f bar dv. So in place of f bar, here how much it is given? Nabla of x square plus y square plus z square. Okay, other things are same. So is equals to triple integration over v. So nabla bar dot f bar. So in place of this nabla dot f, how to find nabla dot f first? So let us write here nabla bar dot f bar. So nabla bar, in our problem f bar is what? In our problem, nabla of x square plus y square plus z square, for this particular problem. Okay, this is our f bar. Already one nabla is there, then f bar is nabla of x square plus y square plus z square. So how to find it? Nabla dot nabla, you all know that is nabla square, x square plus y square plus what? Z square. Now what is nabla square? So nabla square means, nabla square is nabla dot nabla. So in place of nabla, if you write I del x plus j del y plus k del z dot. Again there is one more nabla. Okay. So in place of this first lambda, we have to write I del x, j del y, k del z. And in place of the second lambda, if you again write I del x plus j del y, k del z, then what we have? Del square by del x square, del square by del y square, del square by what? Del z square. Okay, so this is the meaning of nebula dot nebula. So we can write, so here see nebula dot f bar dv, nebula dot f bar dv is how much? Nebula dot f bar dv is nebula square of x square plus y square plus z square dv. Now all the problem, no, you have to practice with me. Otherwise, if you just see the lectures, it is very difficult to understand. So it's better if you do with me, then step by step you'll understand. Okay, if you stuck somewhere, then you just go to the previous lecture also, and you check the previous lecture first, and then if you come back to this particular lecture, then you see that there is a very good connection between these two lectures. So first you check what is the statement, then what are the simple problem that I have done in the first lecture, then you just come back. All the problems are very simple. Okay, now nebula square of x square plus y square plus z square. Just see, in place of nebula square, what we get? Del square by del x square. So del square by del x square, then del square by del y square, and then del square by del z square. This is the value of nebula square. With this, what we have? X square plus y square plus z square, and then what? dv. Since these are partial derivative, so we have to do only we have to differentiate x with respect to x, because other two terms will be 0. So what is the first term? Del square by del x square. So we have to differentiate x square with respect to x twice. So if you differentiate x square once, it will be twice x. If you differentiate it again, it will become 2. Okay, and if you want to differentiate this y square and z square with x square, since it's a partial differentiation, they will become 0. So in the same way, del square by del y square of y square is how much? 2, and del square by del z square of z square is how much? 2. How much it is? dv. So 2 plus 2 plus 2 is what? 6. Then triple integration over v dv, right? So 6 into, like the previous problem, integration v is how much? V. So this is the answer. So when the surface is not specifically mentioned, then triple integration v, yes, we will simply write v. But all the problems will not be like this. See, in this particular problem, the surface is mentioned here. What is the surface? Surface is the sphere. Okay, now this problem is very, very important. So I'll suggest you do this particular problem with me, then you'll see it's very simple. So just by going through the lecture, sometimes it is very difficult. So if you practice, then, because mathematics, you don't read mathematics. Whenever some problem comes, you just do with pen and paper, then only you'll understand, oh, it's this much easy. Okay, so first you have to write the Gauss Divergence Theorem. So nebula dot f bar dv. So here f bar is given. So see, nebula dot f bar. So you can write nebula bar also. So I del del x, j del del y, plus k del del z dot, our f bar is x cube I, y cube j, and then what? Z cube k. So since these are all partial derivative, and I dot I is 1, del del x of x cube is 3x square, del del y of y cube is 3y square, and then what? 3z square. So you can take 3 common, it will be x square plus y square plus z square. So you just simply put, in place of nebula dot f bar, 3 into x square plus y square plus z square, how much? dv. Now see, in place of dv, we cannot write dx, dy, dz directly. So we have to take some transformation. Here, what is the surface? S is the surface of the sphere. So if we consider a sphere, just we have to take the surface, just like a ball we have discussed earlier also. If we take a ball, then we have to take the surface of the ball. So on the surface of the ball, no, you cannot write dx, dy, dz. So because it's a spherical surface. So what to do? We have to take spherical transformation. So maybe some of you heard about Cartesian from Cartesian coordinate to polar coordinate, the relation between Cartesian coordinate and polar coordinate, if in 2 dimensions. See, if this is x-axis, this is y-axis, and if you take a point P x comma y, this, so if we express the point in terms of x and y, then this is our x and this is y, so it's Cartesian coordinate. But the same thing, if you want to take in a different form, then we have to know this angle theta and r. So this is called polar coordinate. So there is a relation between Cartesian coordinate and polar coordinate. It is r cos theta y, and y equals to how much? R sin theta, right? And in Cartesian coordinate, area is written like this, dx dy. But the same area in polar coordinate, we have to write like this, r dr d theta. So maybe some of you know that where from this r comes. This r is called what? Jacobian. So when you take a transformation, something will change. That change is known as what? Jacobian. So here also, since xyz is a Cartesian coordinate, no, but sphere is given. So we have to make a relation between this Cartesian coordinate and what? This spherical coordinate system. So to do that, what we have to do? We have to take the transformation. Okay, we have to take the transformation. So what transformation will do, that we have to understand very, very carefully. Okay, so let x equals to r sin theta cos phi, y equals to r sin theta sin phi, and z equals to r cos theta. So 3 variables, say r, theta and phi. So when we discuss about Cartesian and polar coordinate, in Cartesian and polar coordinate, what happened? We have 2 variables, x and y, and for that we have 2 variables, r and theta. Okay, but in spherical or cylindrical coordinate system, we have to take 3 variables, r, theta and then phi. Why we have to take r, theta and phi? In a simple way I can explain. You see, first you have to take the radius r, then we have to take one angle theta. Okay, this angle is theta. Still it is not a sphere. Now what to do? Now it is a semicircle. Now to make this sphere, what you have to do? You have to rotate it again, na? So when we rotate it again, then there will be another angle, which is what? Phi. So that's why 3 variables, r, theta and phi. So this proof is also there. So if you want, you can find it in any book, or if you want, you just write in comment box. I'll make another lecture to find the relation between this Cartesian coordinate system and spherical polar coordinate system. So in the same way, no, we have a relation between Cartesian and cylindrical polar coordinate system also. So on that particular relation, x and y will be same. So just in place of z equal to r cos theta, we have to write z equals to what? R. Now this relation you have to remember. Okay, r sin theta cos phi, y equals to r sin theta sin phi, and z equals to what? R cos theta. Now it comes to your mind, why this? Now what is the relation? X square plus y square plus z square. See, what is the surface here? Our surface is the spherical surface. X square plus y square plus z square equal to a square. So if you put this x, y, z, no, if you find x square plus y square plus z square, you do this in rough, x square plus y square plus z square, minutely you calculate, exactly you will get this one, r square. So that's why this particular substitution we have to take. X square plus y square plus z square equals to how much? R square. Okay, so this is not mandatory. Now what I said, when we take a transformation, something will change. That change is called what? Jacobian. So the calculation is very big. So here I'll explain how it comes. So if you remember, it's better if you remember the value of the Jacobian, just simply put in the integration. So it's del x of del r, del x of del theta, and then del x of del phi. Similarly, del y by del r, del y by del theta, del y by del how much? Phi. Last one is del z by del r, then del z by del theta, and then del z by how much? Del phi. Okay. Now, how to find this? Del del x by del r. So x we know. So if we differentiate this with respect to r, differentiation of r, partial differentiation of r is what? 1. So what we have? You have only sine theta, sine phi. Okay. In the same way, del x of del theta. So this variable, if we differentiate sine theta, we will get cos theta. Other variable will remain same. Let us write this not here because the calculation is a little bit big. Okay. So what is del x by del r? Del x by del r is sine theta, sine phi. Then del x by del theta. If we differentiate x with respect to theta, you will get r cos theta, cos phi. And then del x by del phi, it will be minus r sine theta. And differentiation of cos phi is how much? Minus sine phi. That's why I wrote minus sine phi. Okay. So in the same way, you have to write the other values. Del y by del r. So it will be sine theta, sine phi. Then r cos theta, cos phi. This will be your r sine theta, sine phi. So differentiation of sine phi is what? Cos phi. And then last one, del z by del r is cos theta. This is your minus r sine theta. Since there is no phi in z, so it will be 0. Now you have to expand this. Okay. After expanding, this value will come r square sine theta. So this particular value now you have to remember. So otherwise, you have to do all these things. So you just remember, in spherical transformation, the Jacobian is what? R square sine theta. Now this is our integration. Okay, this is our integration. Double integration over s. F bar dot ds is how much? Triple integration over b, 3 into x square plus y square plus z square dv. And we see that x square plus y square plus z square is how much? R square. And in place of dv, that what we have to write? Let's just observe very carefully. Okay, so it's double integration over s f bar dot n cap ds is equals to, now right side, triple integration over v. What we have? 3 into x square plus y square plus z square. So that we have to write r square. Is it clear? You see, in place of this x square plus y square plus z square, you have to write r square and then dv. Now dv is, first you have to write the Jacobian r square sine theta, then will be, it become dr d theta and then what? D phi. Okay, dr d theta and d phi, because we have transformed this xyz in terms of r theta and phi. Now we can find the limit very easily. Okay, so 3 is outside. What is the limit of r? So that I'll write here now. How much it is? R square into r square, r to the power 4 dr. We can write them separately also. Then you have to write the value of theta. Theta is to write now sine theta d theta, and finally phi equals to, that also you have to find d phi. Okay, so r to the power 4 dr and then sine theta d theta. Now the limit comes. How to find the limit? You see, what is the radius? What is the surface radius? Is a. X square plus y square plus z square equal to what? A square. So it is given. So r is from 0 to a. The value of r is from 0 to a. Then what we will do? Now we'll rotate it. How much? How much degree we rotate it? See, from here to here. Theta equal to 0 to how much degree we have rotated? Theta equals to 180 degree pi. So limit of theta is what? 0 to pi. Now it is a semicircle, but you have to make it a circle. For circle, we have to rotate this what? Full 360 degree, na? So since it is a semicircle, to make it a circle, to make it a sphere, we have to rotate it 360 degree. So what is the limit of phi? Limit of phi is 0 to what? 2 pi. So is it clear? So what we have now? Phi is 0 to 2 pi. Theta is 0 to pi. and r equal to how much? 0 to a. So r equal to 0 to a, theta equal to 0 to pi 180 degree, and phi is 0 to 2 pi. Now just you integrate it. R to the power 4, integration r to the power 4 is what? R to the power 5 by 5 between the limit 0 to a. This is minus cos theta between the limit 0 to pi. Simple phi 0 to twice pi. This is a simple integration. Now 3 into, if you put the limit, it is a to the power 5 by 5. Then if you put pi, cos pi is minus 1, right? So 1. Then minus, if you put 0, minus 0. So minus 0 is minus 1. And here you will get 2 pi. So 2 to 4. 4 3 is 12. 12 pi a to the power 5 by 5. So this is the answer. So here which part is very, very important? The transformation. Okay. This spherical transformation. So just practice it twice. Then you will see that it is very simple. So in the same way, I'll suggest you practice this particular problem. Okay. So f bar is given here. In the same way you start, S is the surface of the sphere. Okay. S is the surface of the sphere. X square plus y square plus z square. But the radius is how much? 3. And with this center, no, you need not worry, because in the last problem also, no, center is not needed. Okay, center is not needed. The same transformation you do, x equal to r sine theta cos phi, then y equals to r sine theta sine phi, z equals to what? R cos theta. Okay. Then you will get the Jacobian. Directly you write r square sine theta. After doing the calculation, when you come to the transformation, the same transformation you have to write. Now what will be the limit? In the previous problem, r equals to what? Limit of r is 0 to a, but here see radius is 3. 0 to what? 3. Then theta, same theta will be what? 0 to pi, because we have to make a semicircle, you have to rotate from 0 to this, and limit of phi is what? 0 to twice pi. Answer I have already written here is 108 pi. So you do it, exactly the same answer you will get. So in the same way, from any book you do some more problems. So if you practice example number 3 and example number 4, then you see that the other problems are very, very easy. Okay. So I hope you understand these problems. Now from my lecture, if you get some benefit and if you understand my lectures, then kindly subscribe and share with your friends. Thank you very much for watching.